Now let's look at the math functions. To carry out mathematical functions, there are inbuilt Python functions and also dedicated math module that can help you achieve that. There are ones that comes with Python, and there are ones that you use a module to help you do mathematical functions. So we've seen some of them. The built-in functions are POW, max, min, abs, div mode, enumerate, eval, float, int, range, and a lot of them complex. You can use any of these with your pre-installed Python installation. It comes pre-installed with Python, but there are some other things that doesn't come with Python, so you would need the math module to help you do that. So to use the math module, you will have to import it. We talked about that because it doesn't come with Python in the default. Math module has many functions you can call. You can use the DAR functions to see them. You can also use the help functions to see how they work. The DAR functions will help you to see all the functions, all the classes, all the properties that the math module exposes, and then the help function is actually a documentation of the math function, of all the components of the math function. Let me just open that up for us to see. So for instance, if I can import math function right here. If I want to see all the functions here, I can do dir maths. You're going to see all the functions that it gives you. This is seal. Seal is one of it. If you want to see what seal does, you just do help math.seal. So it tells you what that does. So let's take a look at what the math function gives us. Of course, you're going to start using math function. You're going to import maths. So I import the maths function. If I do math.sealing, it basically gives me the upper limit of this number. Let me print it out. So it's going to show 4. Another one is math.floor. It rounds the number downward. I'm doing the same number right now. Okay, let me make it a little bit. So number 3.4. So I'm going to print out math.seal of num. So that prints out 4. It's going to round this upward. And if I print out math.floor of number, it's going to round it downwards. It's going to put it downward. And it doesn't matter if I say it's 3.7. For math.floor, it's going to make it 3. And for math.seal, it's going to make it 4. It's going to round it up. And this will round it down. We also have maths.sign. I'm just going to do some of them. The sign returns the sign of a number. That's sign 10. So I'm just going to put everything. Okay, this number, let me do another number. Num2 equals to 10. So the sign of num2, I'm going to print it out. This is the sign of num2. Let me put some description. So this is the sign of num2. There's also cos. The cosine of num2 of 10. And then there is tangent. Another math function we can do is the exponential function. Exponential returns the exponential number of a specific value. So we have maths.exp, which stands for exponential, and you put in whatever number you want, say exponential 6. This is going to give us the exponential value. Let me print it out here, put it in the standard print. So this gives me the exponential number. let me give it a description. So the exponential of 6 is 4.403 with some floating point there. And another we can have is factorial. If we want to have factorial, let me make a copy of this so that we don't have to do it again. So I'm going to call this factorial, and then I'm going to change these to factorial. So you see the factorial of 6 is 720. Of course, we can also do square roots. So, and that is SQRT. Square root of, let's say the square root of 25, that should be 5. Yeah, square root of 25 is 5. Another one we can have is truncate. Truncate basically removes the floating part of the numbers. Let's say truncate 3.457. Okay, so this is just an example. So I'm trying to put that in the math function. Trunc 23.456. So if I truncate 23.456, it's going to just give me the 23. It's going to truncate. It's going to take out the floating point in the number. Another function we can have is fmod. Fmod returns the remainder of x divided by y. The syntax for xmod is maths.fmod. Then you have x divided by y. This is the syntax. Now our example. Let's divide 20 by 3. So I'll have maths.fmod and 20 divided by 3. And you know, 20 divided by 3 will give you 6, and it will remain 2. 6 remainder 2. So let's print out this. If you see from here, it print out 2. Let's give it a description so you can see it. So 20 divided by 3 will give you 6, and it's going to remain 2. The result for fmod is printed out in floating point. It gives you a decimal number. One of the things you can do with any function is that you can loop functions in functions. So I'm going to make a copy of these and then loop the trunc function in maths so that it truncates out the 0. So I will say maths.trunc. And as you can see, it brings out only 2. Again, fmod will give you the remainder of 2 numbers, and truncate a decimal number to the nearest integer. Let's look at fsum. It's just a sum series of numbers together. So fsum, that'll be maths.fsum. So if I sum 2 plus 5 plus 5 plus 3 and 2, all the numbers you have here will be summed together, but it has to be in an iterable. It's not going to be like this. You're going to put it in an iterable. So I'm going to put it in a list. So it's going to sum. If you remember in one of our examples, we've actually done this as written this function by ourselves, but you know, maths function provides it for you. So if I print out this, it's going to give me the sum of 2, 5. Let me give it a description so that sum of is. So look at it. Sum of 2, 5, 3, 2 is. And of course, I can truncate it also. If I don't want those results coming out this way, I can use the truncate. I can use the seal, you remember, and I can use the floor, you know, to just truncate it to whatever value I want. So there are lots of math function. Like I said, if you want to see all the math function, you can print it out using the door and just say maths, and it's going to print out all the maths functions.